What's up, everybody? This is Mod City Live number 13. What's up, Nelson? Thanks for dropping through. Today we're going to talk about the O Coast, the No Coast,
Cool.
Zero Coast,
The old ghost.
the O Coast. My name is Joe,
My name's Victor.
My name is Sparks.
and this is Mod City Live, as I just mentioned. We are lucky enough to have our old friend Sparks back. You guys don't know Sparks, maybe, but Sparks has been an old friend of ours. He was a student of both Victor's and mine at Point Blank a few years ago, and then he had to go back to Korea, serve his duty in the military, and now he's back making more beats.
Boo 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 boo.
That's right. That's right.
Give
Watch
us
out.
your
He's
give
a
us your
funny guy.
SoundCloud.
SoundCloud. It's 0SPXL, zero special.
And what kind of music are you making lately?
Lately I'm doing experimental hip hop, kind of.
Right on. Yeah, you
Yeah.
were always doing that kind of like lo-fi, a little bit, a little future.
Yeah, kind of.
Yeah.
I don't know what
Yeah.
what the specific genre is, you know.
Well, you guys go check out Sparks on SoundCloud. 0SPXL. Zero Special. All right. Well, welcome, Sparks.
Thank you.
And so, yeah, today we're getting into the O Coast. If you guys have any patch ideas in the chat room, please share them with us as we go. And yeah, let's take a look at the setup here. So, all right, we're one of those channels now. We have bare wood desk, and I didn't have any cacti to put in the image, but we got we got a little bit of Star Wars representation. My coffee, wouldn't be quite right without these things. KD, how you doing? Good to see you.
What
Thanks
up,
for stopping
KD?
through. Wambra,
There we go.
glad to see you. Glad to see your emoji salutation. Yeah. Okay. So, anyone out there in the chat room own an O Coast? If not, get ready. This thing is one of my longtime favorite devices.
Yeah. That's
Um, And so let's maybe disconnect from what we had here. And I'm going to kind of slightly reposition myself so that we can talk about what we see here. Let's move the mic slightly. Okay. So the O Coast. Mic volume is kind of low. Okay, let me see what I can do. Let's turn it up slightly. Thank you for the feedback. How should I say it? Shall I say your name? Da Ju, maybe? I don't know. I don't want to insult you. Thank you for the feedback. Hopefully that's a little bit better. Maybe I can just talk a little bit louder into the microphone. So let's see if we can get some signal from the O Coast. Now, audio is still a little low. Let me know. Any better? Let's try this. And annual special snooker tournament. Wambra, you aren't Steve Davis, are you? Or are you watching Steve Davis compete in the snooker tournament? Steve Davis, of course, is a world famous snooker player. Wim, thanks for joining us. Skull Drazier, hopefully that's the right name. Okay. Wambra, you're not Steve Davis, I guess? Okay. Well, let's try this out. Wambra, feel free to keep the snooker tournament on in another window and stick around with us if you can swing that. Okay, so let's talk about the O Coast a little bit, and maybe we can even zoom in a little bit here. Okay, so the O Coast takes its name from kind of being a collision of, fixing my headphones here, a collision of coastal synthesis concepts, right? We have the we have the East Coast approach, right? The Moog kind of approach, and we'll maybe classify this conversation by saying there's a uh, uh, you know there's a lot of division about whether this coastal comparison is fair, but typically we find people thinking of the East Coast being kind of the Bob Moog inspired approach, where we have a filter to shape harmonic content coming from an oscillator section, harmonic content in the form of, let's say, sawtooth waves, square waves, sometimes triangle waves. And we use a filter to shape the harmonic material that those waves on their own or combined together produce. Rich waves, waves that have many harmonics, waves that tend to sound like strings, brass, maybe woodwinds, instruments that have some harmonic complexity in their tone. Our basic wave shapes, like the square and sawtooth wave, tend to reach into those harmonically similar areas. Um, and then we have the West Coast, more of the Buchla inspired mindset, where we take simple waves and we we jumble them up. I think, Wambra, the term might be additive, right? We have the East Coast, which is subtractive. We start with rich material. We filter away some of that material to, in a sense, simplify the wave content. On the West Coast, or the Buchla approach, we take something simple, a sine wave, a triangle wave, and we add to it by maybe distorting that wave. Additive synthesis could also be considered taking banks of oscillators tuned to the harmonic series or in other harmonic shapes and creating more complex waves that way, using many sine waves, for instance, tuned to the harmonic series will give us a similar shape to a sawtooth wave. So kind of go the opposite direction. We start with something very simple and we distort it in some way, or we add tons and tons of oscillators in some way. Um, and so I think of these things as additive or distortion type synthesis, distortion based synthesis. It's kind of additive would probably properly be assigned or considered that bank of many sine waves, creating the impression of a more complex wave. This might be more distortion based synthesis, maybe more akin to what a guitar player would do to their otherwise very clean tone. They seek out obsessively ways to distort that tone, to make it more complicated, to make it more unique and interesting. And that's kind of what we're doing here. We're using some techniques to alter the shape of our waves and create more harmonically complicated and rich waves. So the O Coast is combining a few of these things. We have the tonal, yeah, and no filter on the West. Typically, in the old school, right? In the original days of West Coast synthesis, we didn't have the type of filter that we have uh, on an East Coast synthesis or synthesizer. But here we are in the 21st century. We've come a long way from when these paradigms emerged, which was in the mid to late 60s. So there's a lot of room for manipulation, for experimentation, for interpretation, I suppose, in how we apply these things, right? We can get a filter from somewhere else and apply it to the rich wave shape, wave distorted material that we get from a distortion type of realm like this. Um, Yeah, it is absolutely getting less and less, especially as people, as developers, as designers explore ways to combine these things. And maybe not just designers as much as the producers, the composers, the sound designers who are combining things from many different places to create new sounds. And, the last 10 years in the bass music scene, for instance, there's so much experimentation in terms of how we generate our wave shapes and how we alter those shapes in the signal path, right? We see now, people like Mr. Bill and some of these other YouTube producers who are advocating, let's see what happens when we put OTT on a track, and what happens then when we multiply that times 100. So we have 100 instances of OTT on a track. And we get into this whole other realm of tonal character. And yeah, we might throw on a filter after all of that, right? We distort the hell out of something and then we dial it back a little bit using our subtractive materials. Um, so we have a few other elements relevant to the East and West Coast showing up on this instrument, as some of you are mentioning in the chat. We have, for instance, um, the contour section, which is very similar in more ways than one to the original Moog circuit, right? It's got a couple of maybe slight permutations, especially this linear to exponential shape knob. This allows us to kind of shape the contours, if you will, of the contour section. This is effectively a an ADSR envelope, something that is especially important when playing combinations of long and short notes. And the this is something that was very important for the keyboard based performance of a Moog synthesizer. This is something that uh, you know Moog made that design decision in the making of his synthesizer to put a keyboard on that device. That made it, of course, imminently approachable to virtually every traditionally trained synth interested musician. It might have been too expensive for many of them, but it made it approachable, something that anyone who had ever spent any time with a piano could play on. Even if they couldn't make a sound, they could play it. And with a keyboard, you need parts of an envelope like sustain, because we might hold long notes. We might play a series of short notes and then play a long note, and we need sustain to make sure that the volume stays high. Make sure that the volume is audible as long as we hold that note, and we want those notes to be heard. So we have an envelope built into this device, very similar to that of a Moog synthesizer, even to the point where the decay knob here is going to control both the decay and the release of the envelope. Um, Wambra, more like using a filter as a VCA, right? We'll still use an envelope to open and close that low pass gate, just like we would to a VCA, which is basically what this dynamics section is over here on the right. This is simply a VCA. We have some level control here. We have automatically routed into that the contour section. And so this is effectively going to control the volume. The dynamic section is sort of I believe, a combination VCA and low pass gate. So we kind of have a little bit of filtering that might happen, but that's going to bring us back to the signal routing of this device, where a filter might not be what we find on this thing. There's some unique decisions made in the making of this synthesizer. So, yeah, there we go. Thank you. A low pass gate It's like a 6 dB filter plus a VCA. And there's something there, right? We can use filters for volume control to a certain degree. In some cases, to a very great degree. Uh, we can do volume change or create maybe a little bit more interesting form of volume change by doing some filter manipulation. Um, so let's take a step back and let's look at what we have in this device. Let's talk about the signal flow through the O coast. And I'm just trying to get my microphone in a sensible location. All right. I'm crammed in here, so. Okay, that seems a little bit better. All right. So let's talk about the signal flow. Now, when we first connect the O coast, we might not have a keyboard connected. We might not have any control mechanisms yet. One thing that we can do is employ this maths section, and we can route the output into our envelope and kind of force it to open up. Okay. Just simplify some things here. So right now, we're basically hearing a droning constant tone thanks to sending a direct current into our envelope. We keep our sustain high and we turn up this direct current so that we can hear what's happening. So, if we follow these gold insignias along the instrument, we're going to be able to track the incoming and outgoing signal flow of the oscillating signal, even the incoming MIDI if we connect a MIDI device to this. The O-Coast comes with one of these MIDI connectors. This end fits right here into the MIDI in jack, and then this end takes a MIDI cable from your audio interface, from your keyboard, from a sequencer, and that signal will come directly in here to the input for MIDI A. And here it splits off some information. CV, this will be your pitch data, right? Any note you play on your MIDI keyboard or notes we sequence in our MIDI interface, plug into the dynamic input. Right here. Oh, I see what you mean. Plug this into the dynamic input. Great point. Then we don't have to worry so much about the sustain, right? Okay, we'll keep that low for a minute. So we'll play with some incoming signal to control this shortly. But we have here an incoming signal that's split. We play a MIDI note, and that's turned into two pieces of information at least. The O coast turns it into at least two pieces of information: pitch and gate. Pitch, again, is the note we're playing. Gate is essentially when we press the note and then when we release the note, right? We play the note, gate opens up. We release the note, gate goes off. Gate closes up. So CV, if we follow this top little line, it goes right up here to control the pitch knob, right? The gate comes down. That's the bottom line here. It goes along down the bottom of the device and goes into the gate input. It's normaled, we could say, to the gate input on our main volume envelope. So when we play a note, we can, with our MIDI input, we don't have to really route anything in the device. It will automatically respond to pitch. It'll automatically respond to note on and off, and we can control our volume shape using the contour section here. So let's assume we have a signal coming in. That signal is, again, converted into some pitch CV. We're modulating the pitch of our oscillator. The oscillator also has its own dedicated 1 volt per octave input, so we'll use that in a minute when we employ our sequencer up here. But the oscillator section responds to the pitch information from either the MIDI input or the 1 volt per octave input. We'll get to the FM in a moment, but the oscillator then generates two signals. There are effectively two oscillators, right? There's a triangle wave circuit, you see that up here, and a square wave circuit. They both pass into the overtone section. If you notice, the triangle wave also goes along down the way here and inputs here to the balance section. Okay, and right now we have this balance knob turned to the fundamental side. This is the triangle wave. Notice it even looks just like our triangle over here. Boom. Okay, so if we turn this up, maybe. Turn this back down. What did I break? Oh, no. Oh, I turned the pitch way down. There we go. We'll turn off our effects. So now we just have our nice dry signal. And this signal, we're hearing the triangle wave, the nice clean triangle wave that's coming out and going right into this balance section. And as long as this knob is turned to the left, pitch is too low. Oh yeah, thank you. Reading your message a couple of moments later. The fundamental knob will then effectively crossfade between the fundamental, the clean triangle wave, and the distorted signal that's generated via the overtone and multiply segment. Okay, this section receives an input from both the triangle and the square wave, passes into the overtone section where the square wave influences the triangle wave, and as we alter the overtone and multiply segments, we're going to get a much more complicated signal. This is effectively going to distort that triangle wave. And now we're starting to influence it with that square wave. We can hear some of the brightness, some of that low frequency content starts to become a little bit less audible. The mix starts to shift a little bit between these frequencies. So the signal comes into the overtone segment where the triangle wave and the square wave are combined. Synth output a bit low. Okay. All the way up. Let's add past the white line. I see what you mean. I can turn it up over here. Maybe that's a little bit better. Oh, we can go still a little bit louder than that. Okay. Yeah, that extra little bit of saturation also going to distort our wave a little bit. Great point. I kind of like that distortion though. A little bit brighter though, right? Very clearly brighter fundamental frequency. So if we bring back over to the overtone side, the overtone segment here, this top portion, takes in our signal from our triangle and our square wave and distorts them, adds them together some harmonically rich way. And then that signal passes out through the multiply output, which allows us again this allows us to shift our harmonic material. Now, let's consider for a moment, what do we use a filter for in East Coast synthesis, right? It's to take something complicated and to make it simpler, to roll off the high frequency content, bring us back down to harmonically simple material. So this is not a filter, but we can maybe employ it as a filter from time to time. And we could even route something to our balance CV input up here and modulate this, right? Maybe have it modulate using our slope section or our contour section. A few options there. But we effectively have an oscillator section with two options: triangle, our clean fundamental option, and we can bring us over to the overtone side where we're starting to distort, alter the tone of this wave. What's up, Decode 303? Thanks for coming in. I think for 303 purposes, this is a very useful tool. Now, one thing we might do, we could take another patch cable and we could route it into, or let's say out of this square wave coming from the oscillator section. We're now patching this over to the balance section. The triangle wave, if you notice, automatically routes all the way over here into that balance section. And then we can override that by routing the square wave in here. Let's maybe turn the volume down for a second. So just with the oscillator section and our distortion circuit here, we can get quite a bit of range of control of tone. And using this balance circuit, we can effectively create a filter like experience in that we can smoothly modulate or set the value of this control to this nice clean input, which can be a triangle by default, or we can route a square wave over here and it can be a square wave, or something much more distorted, much more complex in the form of the overtone side, right? The output of the balance goes into our dynamic section where we can control the volume. You know, I would say for typical use, and maybe this isn't just the O Coast, this is just maybe a bigger outlook on synth programming, on sound design. Subtlety is your friend. Keeping modulation amounts simple will give us nice, noticeable, sometimes very big change. So right? We don't have to turn these knobs very far. To get a great deal of musical motion and change. So we're going to talk about how we can use these other functions to kind of employ that. So far, we've just been kind of listening to a constant droning tone. Maybe that's annoying. So we might look for another way inside of the instrument, fully inside of the O Coast, to trigger notes, right? A sequence, for instance. And uh, for this, it might help to identify some of these different insignia that show up on the different inputs, outputs, ports, things, right? So we can do a lot of control just by hand, but these ports allow us to send signal from one section to another, from over here, to combine signals together using the math section. So, can we employ some of these things? Let's look at the different outputs. Some of these ports have little arrows pointing out of them, right? Those would indicate that they're signal outputs, okay? We have other ones that have arrows pointing into them, like the balance input up here. This is a signal input, and we can send audio signals or slower CV signals, things we might not necessarily consider sound signals or audio per se, um, out of these things or into these things. Now, if we see an arrow in going into a device, it usually is going to mean signal input. And there's really only one of those, I think, on the entire device, and it's this balance input. Okay. Now we see outputs. These are audio or signal CV signal outputs. We could get into a discussion of what's the difference between audio and CV, but effectively they're the same. Audio is just fast enough for us to hear. It's going to be able to move our speakers inwards and outwards faster than a typical CV signal would. So, but in this device, they can operate kind of we can send CV signals into most of the inputs on this. We can send audio signals into most of the inputs on this, and that might give us some other options. Now, what are all the other inputs? Well, we see a lot of these inputs have little white boxes around them. Those indicate that they might expect a CV signal, right? Um, we also see a couple of these devices. This one, the gate input, the trigger input, the tempo input. These all have these kind of not quite concentric circles, these indicators around their input ports. And if you notice, this clock here has an output arrow, but it also has this blinking light, which looks an awful lot like these signals. This is indicating that this is maybe a gate or trigger output. So we see the clock is constantly flashing. Perhaps we could take that gate output, plug it into the gate input on our contour section, and it looks like it's doing something. And now we have a signal. We could tap the tap tempo button up here, the program B button. We could send some other repeating gate signal, a clock from another device, synthesizer, our SQ1 sequencer up here, into the tempo input, and that will set the clock tempo, right? But even internally, we can use the tap tempo. To get some sense of rhythmic motion. Now, that might be super boring. That's okay. We're just getting started. Another thing we might do internally, we might take this random source. If you notice, every time this flashes, every time we hear a note, this thing flashes and changes brightness. That might be hard to see with the light where it is. It's a little bit easier. Okay, so we could take that out and maybe patch that to the 1 volt per octave input. Again, this might be extreme. Maybe we turn the pitch back down. Very extreme. So we might employ this math section to control the intensity of this random value. This is, by the way, a stepped random source. That means that every time the clock steps, this automatically chooses another random value. It holds that random value until another clock pulse, and then it chooses another random CV level. It holds that signal like a direct current, and then next clock pulse, switch again. We could talk more about how stepped random source devices work. This is akin to the Woggle Bug make noise module. So that's something that you can find maybe in a more uh, in depth permutation in the Wogglebug device, or other. There's a bunch of other stepped random modules. The Wogglebug is just a particularly fun one. So we could take that output and we could send it into the input that's directly below it. Okay, take that output and in. Okay, so now when this randomly changes, it's going to send that signal into this device. Now, this knob will control the range, the intensity, the amplitude of that random signal. So if we take another cable and route it out of this maths section, and this is very similar again to the actual maths module from Make Noise. It has 4 channels of this with the addition of rise and fall control on 2 of those channels. And as we turn this up, let's turn up the volume right now. I can try to set it as close as I can get it to 0. That's pretty close. So we're not hearing too much change. Very slight pitch change. And if I start turning this up a little bit, notice that range of modulation of pitch is a lot slimmer, right? We're only going over a very small distance of pitch now. And as I turn up this attenuator, we get a wider range. And we can turn the pitch back down, be more audible. We can even invert that signal. We might need to turn up the pitch because now it's going to go down in pitch. Now, when we invert the signal, it's basically taking that same series of randomized stepped signals, and instead of them going up from whatever pitch we're set to now, it's going to go down in the opposite direction. Instead of, for instance, if this, let's say, randomized to an even +1 volt, then in the positive range, the pitch would go up an octave. If as we go into the negative range, it's going to go eventually down an octave instead of up an octave. It's the negative version, the inverted quality of whatever voltage comes in. So positive 1 volt coming out of the random will be converted to negative 1 volt, or somewhere in between if we attenuate that signal closer to 12 o'clock. So this device rather, takes whatever signal comes in, and it can attenuate it, control its intensity or amplitude, or invert and control the intensity of that inverted amplitude. So the random might not be the most obvious example for this. Another choice that we could employ here for pitch manipulation might be the slope section. This is an envelope, a cyclable envelope, very similar, again, to what we see in the Make Noise Maths module. I'll say the oscillator section is not really like any specific Make Noise module. This section is fairly unique, combined especially with the balance control and the dynamics. Uh, uh, it's a pretty unique circuit. There is a dynamics module, which is basically two of these VCA slash low pass gates. There is a contour module, which is effectively one of these attack, decay, sustain, release envelopes. The slope section and the math section over here, those are basically two of the maybe one and a half channels of the maths module from Make Noise, and the random section is kind of a chunk out of the Wogglebug device. So a lot of ways that we can start to expand this device, but we start to see that there are other influences coming from other Make Noise devices. They've kind of used this as a jumping off point to create new modules. So we might find more functionality by kind of incorporating into this process, accompanying the OCoast with some of those other modules. So the slope section is a triggerable envelope. We can trigger it. We could send it a trigger just like our contour section, and you can see it's flashing here. It rises and falls, much simpler shape than our contour section. And we can employ this cycle function, and that will loop this rising and falling signal, which we could then patch to using this slope out. You might notice it's automatically routed to control the multiply section over here. But if we route it to, let's route it to our attenuator over here. So this is now slowly rising and falling. And I can put that knob as close to 0 and noon as I can get it. That's pretty good. And as I turn it up, that pitch shifting starts to increase in intensity. Might help to hear that just without the gating envelope. Let's see. We could also have that envelope control volume. We could shorten the shape of that LFO. To the point where we might get some FM-like tones. We could intensify that effect, right? We were hardly even doing any pitch modulation. Telephasic workshop, love that name. Um, there is apparently a way to mod the O coast to +5 to -5 volts um, in Eurorack and take this out of the case and put it in a Eurorack case. However, that would of course void the warranty of this device. I think it also might be a waste of um, rack space because this thing has its own power, its own dedicated case for it. Uh, why do a mod that will depreciate the value of the synth, that will take up a pretty fairly large amount of space in the rack when that's expensive space. You pay a lot of money for one row even in Eurorack, and if we take up half of that space with this device, then we might regret it later when we buy more modules and decide, oh, okay, I'm going to put this back in the original case. Then I have to remod it. We could, I just keep this thing right below my Eurorack case and I can route right to it. It's doing its own thing. I don't have to worry about wasting power or space on this thing. I can really just focus on it being in its own space, and I can fill up that rack material, that rack space where I need it. And you need sliding nuts. These might not fit um, M3 uh, size bolts. Yeah, it doesn't fit in standard HP. So, I mean, it's pretty close. I think with a little finagling, you could probably make it work. Again, though, my feeling is this is a synthesizer that will someday maybe be worth some money, right? Make Noise stuff kind of has the reputation of being uh, valuable beyond just as a synthesizer. There's an artistic quality, I think, to some of their synthesizers. To the Ocoast in particular, I find this to be just a very unique thing. There's no synthesizers like this. And if others come along, they will be riding its coattails in a sense. And that's in that case, I feel like I want to maintain this thing in the as close to its original form as possible without you know um, harming this thing. Yeah, you could always fill fill your case with new Behringer modules and aggravate your friends. But the point here is that you might not want to mod this, right? This is like a very valuable device, I think. That said, hey, do it if that's how you feel. Don't feel like someone else is going to tell you what to do with your synthesizer. Um, you can use your rack space however you love. That's up to you. Uh, just to what's up to uh, Tim Daly. What's up out there, man? What's up, Chaos Ladder? Who else is in here? Who else did I miss? I guess Wambra went to the snooker tournament. It's hard to compete with that, to be honest. Okay. Anyway, let's dive a little bit deeper here. Um, so I think the maybe one other thing to mention here about the slope and the contour section, especially. These are our modulation sources, right? This is the that's a great point. Uh, Da, tell me how I should pronounce your name, please, so I can say it correctly. Da Zu. You tell me. Um, the Ocoast has a line level output. So we can go from modular right to line level. We could patch any synthesizer into this balance input. So this can act as a line level mixer in a sense to output to your audio interface, to output into effects chains. Very useful for a lot of these different things. And Yeah, save the HP, right, Nelson? I think there's, that becomes more and more sensible as you fill up that HP and you start to uh, see, okay, well, maybe the things that have their own cases should just stay there so that I have all of this extra real estate to expand with. I can have effects in that space and make it um, a little bit more deep in the case. And then, this thing's so small and portable, you can just slide it into the laptop slot in your backpack or something and take it along with you. Um, okay, so the slope and the contour section, these are our modulation sections, right? The random is also very useful for modulation, but we can take these and we can route them all over the place. And in this sense, it's worthwhile to spend a little bit of time considering what can I do with this thing, even without a sequencer. Um, what can I do with this thing to start to implement some interesting motion? And maybe this connects to how we learn any synthesizer. Um, One thing that we could do is let's take this clock output and we'll send it to the input signal. Now we don't have to send it into this one. We could send it right into this input. This plus this signal sum together, they add together, hence the math, and we can route that out to our gate. And we can route it out also to, let's use a different one, let's use this, to trigger the slope. Okay, so now we've got the slope going, we can turn off the cycle. Maybe we can dial in a nice fast envelope. So we have a rise and fall. This is attack, decay, right? Ramp up, ramp back down. Now we can route that to many places, and that's where we will start. What if we route that to pitch? Go out of the slope output to the 1 volt per octave input. Intense. Now it'd be nice if we could route into the linear FM input, but we can. But linear FM, I think, is you guys are mentioning earlier in the chat there, maybe not the most useful for percussive pitch change like this. Now, another option that we have is we could trigger our slope section, especially if we have a nice fast onset on the contour. We could take our EON. This sends a gate, or maybe it's a trigger, at the end of the onset. So as soon as this segment is finished, it sends a signal. And notice this light, that's indicating the end of onset. And it's lighting up exactly in relationship to the envelope and the VCA. So we could come out of the, there we go, out of the end of onset into the trigger input on the slope. And then we don't have to waste our math section on this gate. We can just plug it right into the clock. And that means our contour section is free. Sorry, our slope output is free, and our maths section is free. So we can route our slope in there and control the amplitude of our slope section with our math control here, with our attenuator. So with no pitch change, nice low triangle wave tone, but with a little bit of pitch modulation, we're going right into the 1 volt per octave input as we turn up that attenuator. Now, keep in mind, we're triggering all of this with a very steady clock. We could just as easily be triggering this gate using MIDI signals, using a drum sequencer if you want to make your kick drums on your O coast. The point here is that by triggering that gate and the slope at the same time, we can independently shape volume. And the pitch change. And we can alter the intensity of that pitch change. We got cats in the studio today. Hopefully you'll get to see them on camera in a few minutes here. Okay, so now we're using our contour for volume. Not only that, we're using it to trigger our slope section. We could trigger them both with a malted gate. That's effectively what we were doing a little bit ago. But now we're kind of using one to trigger the other. Might not work for every situation, but it's working right now to give us a nice bit of shapeability. Over volume and pitch, right? This is where we start with some of this stuff. How can we modulate the simple things, right? And those simple things would be volume, that's the contour section, pitch, right now that's what our slope section is doing, timbre or tone. And there we have some extra help because the slope section is automatically routed into the multiply section. So we could simplify this maybe. Let's take a lot of this out of here. So we're just going back to the clock triggering our notes now. And we'll turn the slope section to cycle. And now we really don't need to do much other than move over to the overtone side. Slope, rising and falling. Maybe we'll set these two around the same settings. This is automatically going to modulate our multiply section. So as soon as we turn up this incoming amplitude knob, this controls the intensity of modulation from the slope section. Remember a minute ago I was saying it doesn't take much. Subtlety is important. Now it's going to take this multiply knob from wherever we set it and turn it up and then back down, right? Rise and fall, like this slope insignia up here. So as we turn that multiply knob up, now if we don't want slope to affect that, we could patch a cable into the slope output. Wrong about that. It just does it anyway. Maybe, what we could do is patch something into the multiply input. And now it's not going to do anything. Of course, if we touch the other end of this cable, maybe it will. Maybe not. Anyway, well, we can interrupt that incoming slope if we take this out. Right, so this is kind of a dummy cable, what we call a dummy cable. It's not plugged into anything at the other end. We could also turn this multiply knob up and turn the incoming attenuator into the negative range. This will turn this knob down and then back up as this rises and falls. Down on the rise, fall will bring it back up to its current setting. So, what if we take maybe our contour output and send it up here into our balance CV input? Might need to turn this up. Whoops. We could also try turning off the cycling. It's another way to kind of nullify the routing of the slope signal into the multiply signal. But we could again trigger our slope section from our contour section. Okay, and then we can use the logarithmic to exponential mode, this control here, to alter the rise and fall shape. At this little line, you can sort of see where this knob is set right now. There's a little white line interrupting this white ring going around this knob. That is indicating a linear shape. Our rise will be linear, kind of like we see in this little insignia. The fall will be linear. As we push further towards the log side, we're going to get more of a hump outward on these types of rise and fall signals. We might perceive this as making the envelope feel longer in length. And you can see it does in fact stay high for longer. If we go the other direction, the slope will take a smoother ramp up. This also kind of has the opposite effect in terms of the overall time of the envelope. Makes it feel like it's going much faster. So we can control the intensity and the length of these, the perceived length of these segments by altering this logarithmic, linear, exponential control knob. We can also alter the length of the decay time, which is also release time on our contour section, using this, which goes from linear to exponential. Again, making our envelopes feel tighter, shorter. This one only controls the decay, though, as far as I know. Okay, let's speed up the tempo a little bit. Okay, so now we've got our slope section doing a little bit of tone manipulation. Come back to the fundamental side, we don't hear any of that. We could also route the slope out to the math again, and then on into the pitch. here, when we go to the exponential side, nice punch. Okay. So, also, I think useful in this discussion would be some basic uh, sequencer, external sequencer routing, right? We could, of course, use MIDI coming in from an external MIDI device, Ableton or our DAW, through, again, this funky 1/8" to MIDI cable. But I think maybe one of the more valuable additions that you could pair with the O-Coast is going to be the SQ1, which is around $100 for a 16-step sequencer, which also acts as a USB MIDI to CV converter. USB MIDI clock to CV clock. Um, uh, Converts signals to little bits outputs. If you have a little little bits Korg uh, modular devices that you can snap together in the form of a synthesizer or whatever, you could send it CV from this as well. This is essentially just a 16-step sequencer with some additional cool functionality for $100. Again, not taking up any rack space. This, I think, is again like another ridiculous deal that you can pair with this thing. So let's just take the CV out, and we're going to send that into the appropriate location on the instrument, which would be the 1 volt per octave input here. Okay, and then we'll take the gate out. See if I can angle these cables a little bit. We'll go into the gate input on the contour. And now we've got a sequence. Well, you can send, Tim, I see what you're saying there. You can send MIDI into, oh yeah, you could send MIDI out from this thing into the MIDI in input, right? The SQ1 has a MIDI output that uses a very similar cable to this one that came with the O-Coast. But worth considering, if we send MIDI out, oh, I see what you mean. We could just literally patch from here to here. We'd need a stereo cable to do that as opposed to our standard mono cables, right? But there's still a problem with this, and that is that MIDI is slow, right? We might not notice so much of that if we are working with just the SQ1 and the O-Coast. But MIDI has a pretty long latency, a noticeable amount of time between when it tries to do something and then it finally sends that information. Not dissimilar to audio latency, right? It's its own limitation of the form of communication, and that's why maybe the CV connection would be more snappy. Okay, that especially if we're using the SQ1 not as a MIDI converter of in any sort, we're just using it as a standalone device. Then we won't receive any of that latency if we're using CV and gate. This is one of the reasons people use CV and gate over MIDI, right? So just a consideration, but I think that's a great point. We can go right out of this output, right into this input with a stereo 1/8" cable that will send the same MIDI information, the same note and gate information in theory. And yeah, so we can get some interesting results out of that. Now, if we turn this back up and we start up the Korg SQ1, maybe shape our decay time on our volume envelope. Very short onset, very short decay. even if we have our exponential knob all the way turned to the left, we get this very, very short volume change, right? Same with sustain. It's all the way down to none. If we turn the sustain up, this is basically giving us, with no sustain, an attack decay envelope. And if we turn up the decay, get a little bit longer tail on that note. We can turn up the onset, we get a longer attack, right? The onset, in quotes, is attack. So here we have basically just an attack decay envelope. If we turn up the sustain, you might notice this if we slow down the tempo. Turn up the duty cycle of each note. So now we have the decay and the onset as short as they can go. So if we send a note, if we send a gate, we only get that snap. If we turn up the sustain, we shift this from an attack decay envelope to an attack sustain release envelope, an ASR envelope. We turn that sustain down to somewhere between none and 100%, then we're really getting that attack, decay, sustain, release type of a shape. And that sustain, below 100%, maybe less exciting for basses, unless we're trying to make, more realistic type basses, I guess. Below 100%, that sustain is going to make, with the sustain below 100%, it's going to make the contour feel a little bit more like it's got an accent at the beginning of the note. Right? For nice solid walloping basses, maybe we want that to be. Okay. Getting starting to run a little bit long here, so I don't want to get into the too much information department. But questions, patch ideas. I think we'll have to do another O-Coast session, a part 2, maybe where we go into especially the program modes, where we can implement an arpeggiator in the O-Coast, where we can implement velocity, mod wheel, things like that, other additional functions, basically. Great question. Tim is asking how or does the pitch range, the voltage range of the SQ1 work? If we hold this duty control, this gives us a function, or like kind of a shift function here. And this allows us to choose on each one of these rows, depending on if we're in 16 or dual 8-step mode, if we're in 1 volt, 2 volt, or 5 volt mode. And this will essentially control the pitch range, right? If we think about 1 volt per octave, that concept of if we increase by 1 volt, we go up an octave in pitch. By that standard, we should see a change of a range of 1 octave with the 1 volt mode. That's what we're hearing here. Maybe speed it up a little bit. To 2 volt. Great question, Skull. The SQ1 is involved in that it's playing the pitches, right? So if we switch to 5 volt, we get this 5 octave range now, and we'll only notice that if we turn some of these knobs all the way up. There we got that 5 volt jump from the last note to the first note. Right? If we do 2 volt, 2 volt, or 2 octave jump from that last note to the first note. These two are turned to their opposite extremes. This one's all the way to the left, this one's all the way to the right. If we go to 1 volt, we can also make these things constrained to a scale, right? Minor, major, chromatic scale, or linear, where the voltages are not constrained to any musical scale. Skull Drazer, gotcha. So we get more atonal, or maybe not atonal, microtonal results in linear mode. You know, the O-Coast is just responding because it follows 1 volt per octave standards. So if we send it a range of 5 volts, we're going to get pitches all over that 5 octave range. If we send it pitches that don't follow a, as we say in the synth world, quantized pitch values, then it doesn't necessarily play notes in a chromatic or major or minor relationship like a keyboard would. It plays them with no regard whatsoever to the keyboard standard, and sometimes we hit in between what we might consider semitonal intervals, right? So it might sound out of tune at that point. So a very useful device. We can have it send, a few different qualities in that sense. Skull, you asked, can the O-Coast clock the SQ1 while the SQ1 sequences the O-Coast? And I would say that probably the answer is yes. Let's try taking the clock output, and we can send it into the sync input on the SQ1. And since there isn't otherwise pitch information, or timing information really coming back and forth, it's just triggering notes. This should, in theory, work. We could send the clock out to the sync in. And notice it's going actually double time to the clock here, because we can set, there's a way to set the O-Coast, or the SQ1's tempo division or multiplication. And right now it's going double. You can see this is flashing at half the rate. In there. So, admittedly, I turned on some clouds for some reverb, and it sounds instantly more musical, right? Any synthesizer that's dry coming right out into the board is maybe going to sound less than impressive, but once we get it going with a little bit of color, yeah. So, Any last questions? I think we'll definitely do another O Coast show coming up. Maybe won't be next week, but sometime very soon. We could certainly employ the O Coast some more. If you guys have any questions, comments, ideas, examples, all these things, we'd love to hear them. Please put them in the chat, or if you come up with some ideas on your own later, come back and give us a comment. Post a comment on the video and let us know what your ideas are. Maybe we'll do them in the next video. Yeah, well, gentlemen,
Yeah. That was pretty interesting.
hopefully that was good for everybody in the chat room. Just a reminder to please, if you will, share our YouTube channel, share the show with your friends, and check us out on Instagram and everything else at Voltage Control Lab on Instagram, at V Control Lab on Twitter. Voltage Control Lab is too many characters for Twitter. Yeah, Sparks, what's your Instagram?
It should be the same. Zero special.
Zero special, zero
SPXL.
SPXL. Sweet. All right. Well, hey, everybody else in the chat room, thanks for joining us. Really appreciate it. Hope you guys enjoyed it, and hopefully you'll see us next week. Come on back. Yes, this will be available. Give it maybe an hour because YouTube likes to spend its time encoding the video, but it will be right back up here on the main channel very quickly after this. Next week, maybe we'll do Max for Live. That was very close on the poll that we ran. So if you guys have any interest in building tools in Max for Live, we're going to get a little bit into that. It's really Max. It's not necessarily even Max for Live. So come on back next week, and hope to see you then. Thanks, guys.